Hello everyone. Myself, Dr. Nidhi Saxena, Associate Professor in the School of Computer Applications, PBD University. I am going to today deliver a lecture on computer network topic. RSC algorithm, the name RSC is being given by the three people, that is Revert, Shamir and Alderman. It was invented in 1977 and it is the most widely used cryptography system. It is based on the block cipher theme, as I have discussed in the earlier lecture, that we have two types of conversion, that is a stream cipher and a block cipher. Block cipher takes a set of bits, not a single bit is being encrypted. It takes set of bits. The algorithm is being shown here. The algorithm says that this is the algorithm which is used for generating the key. Okay, and then encryption and decryption formulas are based on this key. These keys are being used in the formula for encryption and decryption as given in the this diagram. So we take two prime numbers p and q. These two prime numbers are computed, that is they are multiplied, p into q, and that makes n, and fn is being also finded out by deducting one from each and then again multiplying it. Again e is being computed, which is being shown in the formula how it is being computed, and the e comma n becomes the keys for the purpose of encryption. In the same way, for the purpose of decryption, we have two things which are being taken. First is D, that is a decryption key, and N. So the D is also being computed. The formula is being given here, that is D into E modulus Fn is equal to 1. This statement will be proved true, that is it should be equal to 1 by keeping all other computed data into this formula. We can find out the value of D. I will show you in the next slide how, with the help of an example, how do we compute it. There are two keys which are being computed here, that is a public key and a private key. As we know that it is this RSA algorithm is a public key encryption technique, that is we use two keys, public and private. Then we have shown here that encryption and decryption formula, C is equal to P to the power of E mod N, that is encryption, and P is equal to C to the power of D modulus N. C is being used for ciphertext, P is being used for plain text, and N is the number which is being generated in the algorithm as shown in the diagram. Here it is being shown how the encryption is being done in RSA. We can see in the figure that we have a message hello. The public key is being used for encryption. It has two values, that is E comma N, as I have told earlier. E comma N, E is 5, N is 14. Private key for the purpose of decryption, which is 11 comma 14, that is D comma N. We have a message, as I have said, it is hello. Two numbers are being taken. No arithmetic operations we are performing with the string, so the message has to be converted into something. Let's say that the hello is being converted to 2. Okay, and now in the given below diagram, in the figure, it is being shown that hello is being depicted by 2, and how the 5 and 14 are being used in the encryption formula to give an encrypted message, that is 4. That means hello is being converted into 2. Okay, and then it is being encrypted and it makes the value 4. Same in the case of a decryption, the 4 is converted back to 2 with the help of decryption formula, where we have value of d, that is 11, and the value of n, that is 14. Now in this example, we are going to evaluate the value of encryption and decryption key. As I have told earlier that we will take two prime numbers. Here it is being shown that we have taken 2 and 7. 2 is also a prime number and 7 is also a prime number. Let's call it to be an P and Q. That is, and then multiply P and Q to make the value of n, that is 14. Then in the third step, what we do, make a list of 1 to 14. That is from integer number 1 to the value of n, that is 14. We make the list of all the common factors, all the factors, and then remove the common factors as it is shown here, that these values, the 6 values are being evaluated: 1, 3, 5, 9, 11 and 13. They have no common factor. Okay. Now the length of these no common factor is 6. Now there is one of the other way of evaluating, as shown here, that to find the value of L, what we do, Q minus 1 into P minus 1, as I have given in the algorithm. That will also give the value to be 6. That becomes the value of L. Now we get to pick the encrypted key. In the example, it was 5, 14. We now have 14. We know that 14 is the modulus. Okay, so for the encryption key, there are few rules. The rules are that the value should be between 1 and L. L is the length. So the co-prime with L, that is 6, and the modulus with 14. There is only one value which lies between 2, 3, 4 and 5. Okay, 2, 3, 4 and 5, and that is the value 5. So there we came to the conclusion that we have taken 5 as the value of E. Now we have to find out the decryption key, and here in the example we have taken 11, 14, where 14 is the value of n, which we have already calculated. Now we have to find out the value of D, that is 11. So as in the algorithm I have told that there is one of a formula which is to be proved true, then only we can find that that is proved true to be equal to 1, and if any of the value is missing, we can find that value. So in this equation you can see that we have all the values, that is we have the value E, we have the value for the value that is NCF 14, which is being mentioned here, 14, we have the value 14, we have the value E, that in total we have all the values, but only thing which is missing is that we don't have the value D. So if we keep all the values in this formula, and we can evaluate the value of D. Okay, then also there are certain descriptions are being made here, that is how to find out the value of D. So what is being shown here, D into E modulus L NCF n is equal to 1. This is the formula where we are keeping the value. Here I have taken the value 11 and showing that how it is being proved. We can find out this modulus value with the help of a lambda filter. This which is being shown here, it is not necessary to find out this. It is just a description. What can we do is that just keep other values in this given formula, and we can find out the value of D. In this slide I have shown how this formula is being made true. just this is being shown. It is just for proving. It's not necessary in finding out the value of D. You can study it, how I have found it, how I have proved it, the given equation. Now here we are taking another example where the value of P is taken 3, Q is taken 11. We have computed the value of N. Then we have computed the value of In, that is which I have taken in algorithm as Fn. It is the same thing, Fn of In, whatever we want to take, we can take it. P minus 1 into Q minus 1 and then multiplying, that is the value is 20. Then we have taken the value of E and we have computed in the same manner as I have told earlier. The value of E is computed and the value of D is computed. These two values are being used for as a public as well as a private key. Here it is being shown that if the plain text M has the value 2, how it is encrypting the data and how the decryption is being done to find the data back. See, the formulas are being used and the keys are being kept for encryption and decryption. One exercise is being given in this slide. You can use it. The values are being given. You can find out the encrypted text and you can reverse it back and decrypt the text. It can be used as a practice. RSA algorithm is not 100% secure algorithm. Always there have some loopholes in each and every algorithm, but it has less loopholes and it is difficult to crack the keys it generates because it can only be possible if we take the key size to be a very long key size. If we take a small key size, then it will be easy to break. There are certain security issues related to RSA. The first one is brute force. That is, just simply try to find out the value of private key by just having different combinations, by using different combinations. It's a random number. It can be any random number we can take for this purpose. This is one of a type of attack which is on the RSA algorithm. The other attacks are mathematical attacks, timing attacks, and ciphertext attacks, chosen ciphertext attacks. Mathematical attack also are of different type. Like we are taking a factorization method, the factors of the product of the two primes, that can make some problems